Welcome to another unit of the ISM exercise set Business Mathematics. This time with a unit on Extrema. Let's take a look at the exercise. Here we have calculate all possible extrema of the following function. The function here is the f of x and y. So what we are doing is first copying the function here and then considering the first derivatives. For the first derivatives, we only concern ourselves with these terms in the function where we have the corresponding variable for which we are actually deriving. So when we consider the derivative for x, only the terms where we have an x are actually of relevance. So here it's the first and the third one. And if we derive them for x, we get 2x times y to the power of 3 plus 2. Then if we take the parts which are relevant for the derivative for y, that's the first and second, we derive them, we get 3 times x squared y squared minus 3. So it looks as follows. Then we set both of these parts equal to 0 and reformulate them. So here we divide by 2 and bring the number to the right, and doing the same thing for the second one. And it looks as follows. Okay, what does this help us with? Well, first off, we see that's something we need later on. If we were to have an x or y which were 0, this would directly result in some kind of problem, because we would have either 0 being equal to minus 1 or 0 being equal to 1. So neither x nor y can be 0. So this keeping in mind, we can then again consider the second one and just divide this by y squared. And we have x squared is equal to 1 divided by y squared, and we can take the square root. However, here we need to consider that this can be positive or negative. So here we get as a result x being either plus or minus 1 divided by y. With this as a result, we can insert x being equal to 1 divided by y, so the first case, in the first of our equations, giving us here, because they cancel or shorten themselves out, y squared being equal to minus 1. Well, this is not possible, so we do not have to concern ourselves with this situation anymore. So instead, we insert x being equal to minus 1 divided by y in the first one, and we get minus y squared is equal to minus 1, giving us here two possible solutions, which are plus and minus 1 for y. Well, if y is plus minus 1, the corresponding x is minus plus 1. So here we have two possible extrema. 1 minus 1 and minus 1 plus 1. That's the two. And then we need to check whether they are minima, maxima, or saddle points. For this, we're going back here, copying again the function and the first derivative, and now we're needing the second derivatives as well. So we work our way through the first derivatives, first off taking for both of them the derivative with regards to x, giving us the first column of the Hesse matrix, and then we derive both of them with regards to y, giving us the second column of the Hesse matrix. So with regards to x, we get 2y to the power of 3 and 6x y squared. And with regards to y, we get 6x y squared and 6x squared y. So it will look as the parts here. So always keeping the one variable which we are not deriving for as a constant. And then we just apply the rules which we know for deriving polynomials. Okay, what to do with this? We just insert the two possible extrema we have here in this Hesse matrix. So we start with the first one, 1 minus 1. This gives us here in the upper left a minus 2, so a negative value, and the determinant of the Hesse matrix in this case, so minus 2 times minus 6 is 12, minus 6 times 6 is negative, 12 minus 36 is negative. So if both of these values are negative, this shows that we have a saddle point at 1, minus 1. Then we do the same thing again for minus 1, 1. Here, the upper left one is positive and the determinant of the Hesse matrix is negative. More or less same result as before. We have again 12 minus 36. So again, we have a saddle point. Well, so we found out we have two possible extrema, 1 minus 1, minus 1 plus 1. However, both of them are saddle points. This then concludes already this exercise, and I hope you enjoyed listening to it. If you're looking for more exercises, feel free to visit the rest of this exercise set or take a look in the corresponding playlist. I say goodbye and see you next time.